Hello there, welcome to this Shieldia guide where I'll be going over the content security bypass within the damn vulnerable web application on low security. This is a relatively simple bypass, it's only on the red team perspective. However, we can get more advanced with how we interact with the CSP and set our own custom JavaScript, even though the developers say we can't do that anymore. We can. Just takes a little bit of setup and it's a little bit beyond the scope of this low security module. However, I hope you join me in having a look at how we can do that. First of all, like always, you're going to need the prerequisites. This being only red team, just bring up the red team related stuff unless you have a damn vulnerable web application pre-existing. Again, as always, we'll start with the basic browser. We will log in. Once you have logged in, set the appropriate security to low, and then navigate to the CSP bypass page, where you will see a list of hosted directories that DigiNinja provide. We can have a look at, for instance, this one, the damn vulnerable web application directory, and then the specific file alert.txt, and we'll see what that comes back with. So you hit include, nothing happens. Okay, interesting. If we instead use the alert window, we'll get something. Oh, CSP bypassed. Now, why is that? I'll cover for you today. And then you can have a look at the rest of these and try to figure out why some work and why some don't work on your own time. Moving on to explaining why the JavaScript ones do in fact fire, is there is a content type header that's being set by the server to tell the web browser that this specific content should be served as JavaScript and not be served as, if you look here, plain text. I want to make it clear, DigiNinja is completely out of scope. You can do maybe 1 or 2 curl requests, but maybe it's honestly up to them how they want to deal with it. If you wanted to see why it works, this is why it works. You don't even have to interact with it. So it's saying the paste bin method no longer works, but there are other ways we could modify. Granted, this is again out of scope, the context of this challenge, but how we can modify these things to be in our favor. I was looking at how the content security policy DNS or domain name system resolution works. I was under the initial impression that it would resolve on the server. That is not the case though. The DNS resolution happens on your local host. What does that mean? That means we can change in the etc host file any of the security policies that are in place to point somewhere else. Granted, again, a bit out of scope and a bit niche, but to demonstrate this, we will take example.com. Again, do not attempt anything with it. Example.com is an actual real domain. It does actually serve stuff, so please do not actually engage with it. However, we're using it by way of example here. The first thing we're going to want to do is look at the content security policy. So this would be within the content security policy header in the web page. If we do an inspect element and then networks tab, we'll do a reload and then resend. Okay. Here we'll see within the headers that are the response headers that are sent from the server, we have these specific domains, pastebin, blah, 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 and one of them being example.com. So we can use that to our advantage. You could use any of these if you wanted to. However, in this example, we'll use example. First, we want to edit the local etc hosts file. To do that, there are a few ways. You could sudo vi, sudo nano, sudo whatever. Another way you could do it is sudo bash, which will give that specific command, if you pass the C flag, sudo permissions, because etc hosts is a protected file. We'll do that now, applying it to the hosts file on the Kali guest. Now this will echo this IP address to resolve to example.com and then append it to etc hosts. So if we do a cat etc hosts, it'll tell us, okay, example.com will now resolve to our local IP address. We do an IPA, then that'll give us our local IP address. That'll resolve to. Why do we want to do this? So that we could then serve our own custom JavaScript locally. Again, a bit of a contrived example, but is just going to show you that these things are still possible. So we'll create another file, look I'm on TV, well, alert.js, that's going to contain alert look I'm on TV. So this will be a plain text file served locally here, but we can cat and then cat it, alert look I'm on TV. I'm going to clear the screen, again go cat alert.js to look at what the file is. So it's just a little, as we've done before, a simple alert. So it is just a text file. There's no easy way to, well, there's no way that I can show you now that it is in fact just a text file. However, we can then tell a server what MIME type it should respond as, which is what we're going to do now, providing it with a piece of code here. Again, a little simple Python server, but we're going to change the way that the Python server is actually responding. What we're going to tell it to do, we'll import Python, the HTTP server, so the simple HTTP server. Then one of the classes we're going to change to actually modify the MIME types, or the media types now that they're referred to as. So we're going to say any file that ends in .js, we'll do a response code 200. We'll tell it that the content header, the content type header, should be application JavaScript. And then we will read that file and then respond that file. So here we could see we're defaulting to port 80. This, again, you might need to bless Python with that capability. We're not going to worry about that now because you should have probably already done that. So we'll create this Python server file as well within the Kali Linux instance. We can do nvim. Oh no, I don't have neovim installed, so we'll just do a normal vim server.py. Then we will input all of that code. We can then do a python 3 server.py. This will then start that server for us. Then we can, so now we're serving that file to whatever web server we're requesting within the content security policy. We can now input that as one of the tests within the damn vulnerable web app. So none of the listed ones here, but if we input it to include it, it'll then go, the name resolution looks up in the local resolver. Oh, okay. In etc hosts, we've put a resolver to say example.com will resolve to 192.168.56.200. And then that content is then served by our local system. And then we can have JavaScript, custom JavaScript. It's relatively simple, but it does work. So that's by way of example. And that's all there is for the content security bypass on low security. So thank you for joining me, and I'll see you in the next one.